Hello students, today let us prove some trigonometric identities. These are very important questions. These will appear for 3 marks in your exam, mainly 3 to 4 marks you can ask, maybe. Okay, these are very important questions. You have to learn thoroughly and you have to know the techniques behind these things. Okay, so I will tell you what we have to do here to prove this. We cannot have the idea directly. Just you have to look over the LHS and RHS. Okay, we have to prove by taking LHS or RHS into LHS here. Okay, we have to prove this. For example, let us consider one of the trigonometric identities, that is cosecant theta minus cot theta whole square is equal to, we have to prove it as 1 minus cos theta by 1 plus cos theta. For that, let me consider this LHS here. Left hand side is cosecant theta minus cot theta whole square is there, no? So that is equal to, just you transpose this cosecant and cot to sine and cos. It is very easy, as we know that. So to represent this cosecant theta is reciprocal of sine, no? That is 1 by sine theta you write, minus cot is the ratio of cos to sine, is it? Cos theta by sine theta whole square. Okay, now you take the LCM here. So LCM of these two is sine theta. Okay, so again 1 minus cos theta left here in the numerator whole square, is it? So just you split this one. We have to see what we have to get as a RHS here. So based on that we have to convert, okay, using the trigonometric relations. Now you see in the numerator, let us split this square, 1 minus cos theta whole square by sine square theta. We can write, no? So therefore, now you see here, let me transpose this sine square theta as 1 minus cos square theta. Okay, 1 minus cos square cos whole square by, it can be written as, sine square theta can be written as 1 minus cos square theta. How? You see, since we know that sine square theta plus cos square theta is equal to 1, no? So if we transpose this cos square theta to right hand side, sine square theta can be written as 1 minus cos square theta in this way. Okay, just split this one. So meaning of square means we have to write this as 2 times, no, product of 2 times 1 minus cos theta into 1 minus cos theta we can write. This is same as, let me write this 1 as 1 square. 1 square minus cos square means a plus b into a minus b we can write, no? This is same as a square minus b square. Therefore, 1 minus cos theta into 1 plus cos theta we can write. Now, one of the 1 minus cos theta will get cancelled. So we get the RHS. You see same, that is 1 minus cos theta by 1 plus cos theta is the RHS. In this way, we can prove the identities here. Look this identity. One more identity here. So that is second one. So cos A by 1 plus sin A plus 1 plus sin A by cos A is equal to 2 secant A we have to prove. So here you see in the LHS we are finding, so this as cos A by 1 plus sin A plus 1 plus sin A by cos A. Here it is as usually it is very easy, no? It is in the same, it is in cos and sin only. Therefore we can see this LHS, RHS, only simply we have to prove it as 2 secant A, no? Take the LCM of this one, just it is enough. Take the LCM. LCM means it is the product of the denominator, that is 1 plus sin A into cos A. So here in the numerator cos A into cos A is cos squared A plus 1 plus sin A into 1 plus sin A, 1 plus sin squared A, sin A whole square. Okay. Now you see here, this is cos squared A is there plus 1 plus sin squared A is there. So just you have to expand this A plus B whole square form. Okay. Keep this cos squared A as it is plus you expand this using the identity A plus B whole square, that is A square is 1 plus B square is sin square A plus 2 sin A, 2AB, no, 2 sin A by, here you see in the denominator, you keep that as it is, 1 plus sin A into cos A. Okay, now look at the numerator, you will see one thing, that is cos squared A plus sin squared A, is it not? As we know that sin squared A plus cos squared A is equal to 1 using the standard identity. So we can write this, instead of this we can write 1 here, 1 plus again one more 1 plus remaining thing is 2 sin A by, here you keep this as it is, it is 1 plus sin A into cos A, that is equal to 1 plus 1 is 2 plus 2 sin A by 1 plus sin A into cos A. Okay, so you take 2 common here, 1 plus sin A left, so 1 by 1 plus sin A, 1 plus sin A into cos A. Now you see here 1 plus sin A, 1 plus sin A will get cancel, so we can write 2 into 1 by cos A. What is 1 by cos A? According to trigonometric inverse function, that is inverse of cos is, that is reciprocal of cos is secant, no? 2 secant A is the RHS. We can prove these as like this. Okay, look this one more, that is we have to prove that square root of 1 plus sin A by 1 minus sin A is equal to secant A plus tan A. Let us consider the LHS here, that is square root of 1 plus sin A by 1 minus sin A. So as we have to remove the square root here, no? Therefore let us go for rationalize the denominator, then we can have that clearly here. That means this is equal to rationalization of the denominator, means you see here 1 plus sin A by 1 minus sin A, multiply and divide by 1 plus sin A, 1 plus sin A by 1 plus sin A. There will be nothing change in this one, that's why. So rationalizing factor of 1 minus sin A is 1 plus sin A. So multiply and divide by 1 plus sin A here, that is equal to square root of, you look at this numerator, 1 plus sin A into 1 plus sin A is 1 plus sin A whole square we can write, no? So similarly here 1 minus sin A into 1 plus sin A is 1 minus sin A into 1 plus sin A is 1 minus sin squared A we can write, is it not? 1 minus sin squared A, that is A plus B into A minus B is A square minus B square. So that is 1 minus sin A, 1 square is 1 itself. So again 1 minus sin squared A is cos squared A. Since as I told you in the first problem, 1 plus sin A whole square by, we can write this denominator as 1 minus sin squared A is cos squared A. So since as we know that sin squared A plus cos squared A is equal to 1 now, so that means cos squared A, that is 1 minus sin squared A, means cos squared A can also be written as 1 minus sin squared A. So take the sin square A towards your right hand side, you will get. So here square both squares are there, no? Now we shall write this together, that is 1 plus sin A by cos A whole square we can write. Now this square root get cancelled. Now 1 plus sin A by cos A. Split this one, cos A, distribute this cos A to 1 and 1 sin A. You will get 1 by cos A plus sin A by cos A. Okay, so you see RHS will come, 1 by cos A is secant A, reciprocal of cos, sin A by cos A is tan A. Okay, this is RHS. Look at this example problem, dear students. We have to prove that we are clubbed these that is complementary angles and trigonometric identities are clubbed in this one, that is cot squared of 90 minus theta by tan squared theta minus 1 plus cosecant squared theta by secant squared theta minus cosecant squared theta is equal to 1 by sin squared theta minus cos squared theta we have to prove. Okay, so that is 1 by sin squared theta minus cos squared theta we have to prove. Therefore again let us consider the LHS here, LHS is same as, that is cot square 90 minus theta by tan square theta minus 1 plus cosecant square theta by secant square theta minus cosecant square theta. Okay, that is equal to, as we know that cos squared of 90 minus theta is cos of 90 minus theta is tan theta, no? So that is tan squared theta we can write according to complementary angles, you know that. So that is cos of 90 minus theta is tan theta, no? So cos squared 90 minus theta is, that is cot squared 90 minus theta is tan squared theta we can write, divided by, take that as it is, that is tan squared theta minus 1. Tan squared theta minus 1 you take as it is in this step. Now cosecant squared theta, leave this as it is, cosecant squared theta by secant squared theta minus cosecant squared theta. You keep that as it is in that step. As I told you, if tan cot or come means we have to go for this transposition, that is sin to cos you can write. This is very easy because we have to get sin in these in terms of sin and cos, no? That's why transpose this tan is defined as sin by cos, no? Write that tan squared theta as sin squared theta by cos squared theta. Okay, again here also you write sin squared theta by cos squared theta minus 1. Okay, plus here cosecant squared theta, cosecant is same as 1 by sin squared theta, no? Divided by secant theta, again 1 by cos squared theta minus cosecant is again 1 by sin squared theta. Okay, now again you go for this taking the LHS here, that is LCM here. LCM means here cos square, that is in the numerator you keep that as it is, that is sin squared theta by cos squared theta whole divided by, here LCM is cos squared theta only. So cos squared theta you take LCM, sin squared theta minus cos squared theta you will get. Okay, plus here also you keep that 1 by sin squared theta as it is. Now here what is the LCM? Sin squared theta, cos squared theta into sin squared theta, or sin squared theta into cos squared theta is the LCM. Okay, so that means here sin squared theta into 1 is sin squared theta minus cos squared theta 1 is cos squared theta. Okay, so in this way we can take the LCM. Now you see this cos squared will get cancelled. Okay, that's only here, nothing change in it, that's only cancels. Okay, remaining thing in this one is sin squared theta by sin squared theta minus cos squared theta left, plus you take this to the numerator and this to the denominator. Here you see sin square will get cancelled only. Okay, cos remains same, this sin squared theta will get cancelled, cos remains same, that is cos squared theta by sin squared theta minus cos squared theta. Now the LCM is sin squared theta minus cos squared theta, remaining thing is sin squared theta plus cos squared theta left in the numerator. LCM is sin squared theta minus cos squared theta. Now as we know that sin squared theta plus cos squared theta is 1, no? So divided by sin squared theta minus cos squared theta, since sin squared theta plus cos squared theta is equal to 1. So which itself is the RHS. You see, in this way we can prove. Dear students, these are very important problems. Okay, there are so many trigonometric identities you have to prove. Let me give some homework and also let me solve some more problems here, okay, in the next class.